Hello and welcome back. In today's video, we're diving into the exciting world of Rotten Tomatoes movie rating predictions. Rotten Tomatoes is a popular website that aggregates movie reviews from critics and audiences, providing a score called the Tomato Meter. This score reflects the percentage of positive reviews, classifying movies as rotten fresh or certified fresh. A movie is considered fresh if it has a Tomato Meter score of at least 60%, while anything below that is labeled as rotten. Certified fresh has a special distinction given to high-quality films that have a steady score and meet specific criteria. In this series, we will explore two different approaches to predicting movie ratings on Rotten Tomatoes to build models that can evaluate a movie's status as rotten or fresh based on different features. Our first approach will focus on predicting movie status using numerical and categorical features, while in the second approach, or the second series, we will analyze the sentiment of movie reviews. Throughout the video, we will compare our model's predictions to the actual data to evaluate its performance. By the end of this series, you will have a deeper understanding of how Rotten Tomatoes movie ratings can be predicted, and you will gain valuable insights into machine learning techniques that can be applied to similar problems. But before we get started, if you want to learn more about data science, hit the subscribe button. Alright, now grab your popcorn and let's dive into the world of Rotten Tomatoes movie rating predictions. Before delving into our methods, let's download the datasets and import it into your Jupyter notebook. Although various algorithms can be used to build a machine learning model, we will concentrate on tree-based algorithms, specifically the decision tree classifier and random forest algorithm, for predicting movie status in this task. To gain a deeper understanding of the learning process for these algorithms, you can find the link to an article that provides an information in the description box below. So let's begin, and let's start with importing all of the libraries necessary for this challenge. Now, in our first approach, we will predict the status of a movie based on numerical and categorical features. But before diving into it, let's first see our dataset. Our dataset is in CSV format, which contains information about movies, which we will go deeper into in the next stages. In this code, we will use the pandas library to read and view our data frame. So here's the code and here's the preview of the dataset. As you can see, there are several columns available on our dataset. So Rotten Tomatoes link of the corresponding movie, the movie title, the synopsis of what the movie is about. That's what movie info is. A content rating is the rating of the movie's stability for certain audiences based on its content. And we've got genres, directors of the movie, authors, which could be screenwriters, and we've got the original release date, and there's a production company of all the production companies of the movies, and we have Tomato Meter status. Here we've got rotten, certified fresh, and fresh, and so on. So this will be our Rotten Tomatoes numerical rating, and we also have a count. So this would be the number of critics' review of a movie, and we've got audience status. This is a movie's classification from audience review, and audience rating is the numerical rating from the audience. Audience count is just the number of audience reviews of a movie. The Tomato Meter top critics count is just the number of top critics who've reviewed a movie. Tomato Meter fresh critics count is the number of top critics who reviewed the label as fresh. And Tomato Meter rotten critics count is just the number of critics who reviewed the movie as rotten. To understand our data a little bit better, let's take a look at the summary of our data. So here's the code. We'll just use the describe function. So using the describe function just gives you a little more information about the data set. All right, now let's get started. In our dataset, we can see that there are several numerical features. We will use these features to predict our target variable, which is the tomato meter status. It is important to note that some of these features have missing values, which we need to handle later. Let's consider the content rating variable. This is a categorical feature with distinct values like R, PG, NR, etc. To better understand its distribution, let's visualize the data. The first step is to print the unique content rating categories in our dataset. Next, we will create a bar plot to visualize the distribution of each content rating category. So here's the full code, and let's run that. So this is the output. Since our machine learning algorithms require numerical inputs, we need to convert these categorical features into numerical representations. There are two common methods for this: ordinal encoding or one-hot encoding. We will use both approaches for different features in this project. Ordinal encoding is preferred when categories represent a degree of magnitude, whereas one-hot encoding is preferred when categories don't represent any degree of magnitude. In this case of content rating, we will have to use one-hot coding. And here's the code. And let's run it, and here is the output. Now let's pre-process another feature, which is audience status. This variable consists of two categories, spilled or upright. Since each category represents an order of magnitude, we will use ordinal encoding to convert these categories into numerical values. First, we will print the unique audience status categories, and next we will create a bar plot to visualize the distribution of each audience status category. At the top of these bars, we will use the value by selecting the first element of the container. That's the full code, and let's run that. Let me zoom out for your convenience, and here's the output. Now let's perform ordinal coding on the audience status variable, and here's the code for that. In this code, we will use the pandas data frame method with replace method inside, with arguments corresponding to spilled and upright to perform ordinal encoding. And here's the output. Next, we need to convert our target variable, which is tomato meter status, which has three unique categories: rotten, fresh, and certified fresh. Since these categories represent an order of magnitude, we will use an ordinal encoding. By using the replace method inside the pandas data frame method, which is used to create a data frame, we will replace these texts with 0, 1, and 2. So here's the code for that. And let's run that, and here we have the output. Having converted the necessary variables, we can now combine them with the remaining numerical features to create our final data frame. We'll use the pd.concat method from pandas, and we will remove any rows with missing values in any columns by using the dropNA method. And then we'll use the head method to check the data frame that we created. And here's the code. And here's the output. All right, now let's see this data frame statistical information for each of our variables, and here's the code for that. So we'll just use the describe method. Now let's check the length of our data frame by using the length method. So our final data frame contains 17,017 entries after removing rows with missing values. Now let's analyze the distribution of our target variable, tomato meter status, and here's the code for that. And here's the output. So we can see that there are 7,375 rotten movies and 6,475 fresh movies and 3,167 certified fresh movies, indicating a class imbalance problem. So we'll need to address this issue later. For now, let's split our data into training and test sets using an 80 to 20% ratio. So in this code, we will first draw a bar graph with the same approach as we did here, and then we will split them into train and test set 0.2 and 0.8. And finally, we will check the lengths of these datasets. So here's the code. And let's run that. So the size of the training data is 13,613 and the size of test data is 3,404. So with the data reprocessing complete, we are now ready to build our machine learning modules and starting with the decision tree classifier. But stay tuned for that. That will be the next part in our series of data project from Rotten Tomatoes. I'll see you later.